Now, the consistency of clay soil. Water content alone, therefore, is not adequate index of consistency for engineering and many other purposes. Consistency of soil can be expressed in terms of liquid limit and unconfined compressive strength of soil. Water content only cannot explain the consistency, so liquid limit, unconfined compressive strength is necessary for the consistency analysis. This is Atterbuck, Swedish scientist, considered the consistency of soil in 1999 proposed a series of tests for defined properties of cohesive soil, indicate the range of plastic state of cohesive soil which possesses the ability to undergo changes of shape without rupture. Another state, the transition state from liquid state to plastic state is called liquid limit. At this stage all soil possesses certain small shear strength, thus strength is started on soil. The transition from plastic to semi-solid state is plastic limit (Wp). Water content is Wp, corresponding water content at that state, transition state. At this state, the soil rolled into threads of about 3 mm diameter just crumbles in plastic limit. Further decrease of water contents of the same will lead finally to a point where the sample can decrease in volume. No further decrease in volume condition. This point At this point sample begins to dry at surface and saturation is no longer complete. Further decrease in water in the void occurs without change in void volume. The color of the soil begins to change from dark to light. This water indicates shrinkage limit (Ws). This limit are all the percentage of water content. Plastic limit. Now plasticity index equals to liquid limit minus plastic limit is equals to plasticity index. This is liquid limit, liquid limit, plastic limit, shrinkage, and solid state. This is the transition point at which just shear strength is started to gain on the soil on further decreasing this volume, and this is water content. Volume is also decreased on decreasing water content. The soil just crumbles plastic state. Volume is also decreased and semi-solid state is obtained. This is shrinkage limit. Almost volume remains constant from this semi-solid to solid state, only decreasing the water content. This is called liquid limit, plastic limit, shrinkage limit, and That's all. Liquid limit and plastic limit equals to plasticity index. Determination of liquid limit. These Utterberg limits are liquid limit, plastic limit, shrinkage limit. This is Cassinger liquid limit tool for the determination of liquid limit. And its number of blow. C is a constant. IF equals to slope of flow curve. Water content W equals to minus IF log n plus C. The water content corresponding to 25 blows is termed as the liquid limit. In Casagen-Ray liquid limit approaches, the mm, liquid the water content corresponding to 25 blow is termed as liquid limit. And this liquid limit analysis, liquid limit test. So water content equals to minus IF log n plus C, that is 25. N equals to 25 plus C is any constant IF flow curve. Slope of the flow curve by single point method. Liquid limit WL equals to W n by 25 whole power n, where this W is equals to water content at 25 blows corresponding to 25 blows. This apparatus is used to revolution per second is applied on the blow. Blow is applied in 2 revolutions per second. Liquid limit by Falcon method. Penetrometer Falcon penetrometer method. W liquid limit equals WI plus 0.025 minus by WI plus 15, where this plastic limit. About 20 gram of soil passing through number 4 sieve 4.75 mm sieve, that is 40 sieve is mixed truly. For number or 40, I confused. The soil is rolled on a glass plate with the hand until it is about 3 mm diameter, and the procedure of mixing and rolling is repeated till the soil shows sign of crumbling and the corresponding water content is determined. This is called the plastic limit. Liquid limit is just shear strain is started on the soil and plastic limit when the soil crumbles. Next one, shrinkage limit by following method can be determined. When the specific soil is unknown, the shrinkage limit corresponding water content is when the specific gravity is known. To method when is unknown, shrinkage limit equals to this. Soil mass of solid ms and container volume b naught, mass of specimen m naught, The specimen is sample is then dried and till it reaches the shrinkage limit. This is represented by block diagram B, and the specimen remains up to saturated up to this limit but reaches constant volume BD. Constant volume when the specimen is completely dried, its mass will be ms, volume will remain as BD. Then W as shrinkage limit m naught minus ms minus b naught minus bd rho wms into 100%, where m naught equals to mass of specimen, b naught is volume of the container volume, ms is mass of sample mass of solid ms. Determination of dry volume of sample by displacement in mercury, bd. ws equals to mass of water by mass of soil into 100% at shrinkage point. Mass of water equals to dry volume minus volume of soil into density of water, mass of water. BD. No water, soil and air. Okay. Discussion on limit indices. They may be just at borderline between the plastic and non-plastic in such way non-find the liquid limit practically and with the plastic limit and plasticity index equals to 0. Liquid limit practically identical with the plastic limit. Liquid limit equals to plastic limit, then plasticity index 0. There are some fine-grained soil that appear similar to clay but they cannot be rolled into threads so easily, so such materials are not really plastic. Cannot be rolled, cannot be crumbled, not plastic. They may be just at borderline between plastic and non-plastic soil, that is liquid limit equals to plastic limit case. Then plasticity index 0. Materials are not really plastic. Plasticity index equals to liquid limit minus plastic limit plus 0. Non-plastic less than 7 low plastic, 7 to 17 medium plastic, greater than 70 highly plastic. Clay soil. Toughness index IT. IT equals to IP by IF. Plasticity index by flow index IF. Flow index IF. Liquidity index equals to WN minus WP divided by IP. liquidity index. Consistency index IC equals to liquid limit minus WN divided by IP. Liquidity index IL plus consistency index IC equal to 1. Shrinkage and swelling of swell SR. The degree of shrinkage SR equals to B naught minus BD divided by B naught into 100%, where B naught equals to original volume of swell sample at saturated state and BD equals to final volume of sample at shrinkage limit. This is the shrinkage degree of shrinkage. Origin volume at saturated state B naught minus BD, that is final volume at shrinkage limit divided by V naught into 100%, equals to degree of shrinkage. Shrinkage ratio SR is equal to SR equals to gamma D by gamma W. The shrinkage ratio of soil mass is equal to the mass specific gravity shrinkage ratio. SR equals to gamma D by gamma W, rho D by rho W. Mass specific gravity equals to shrinkage ratio SR. Volumetric shrinkage SB equals to V naught minus VD divided by VD into 100%. This is the general formula. V naught minus VD by V naught into 100%. Then this volumetric shrinkage SB equals to this W naught minus WS into SR. Linear shrinkage equals to 1 minus 1 square 1 by 3 by SB plus 1 into 100%. L naught minus LF divided by L naught. Consistency of swell analysis is by unconfined compressive strength. That is, we have discussed index property, that is shape and size by CV analysis, hydrometer analysis, and Stokes law analysis, and other consistency and relative density analysis. Consistency analysis is done by using that water content analysis and Otterberg limit, that is liquid limit, plastic limit, etc. And now by unconfined compressive strength analysis. These two methods for consistency and relative density, CV analysis, and other for grain size, particle size, shape and size analysis. Grain swale grain analysis, shape analysis, and consistency analysis. This consistency unconfined compressive strength less than 25, very soft, 25 to 50, soft, 50 to 100 medium. This is just a very stiff hard. This is the main result of the unconfined compressive strength analysis. Analysis of sensitivity classification. This sensitivity ST equals to QU by QU dash. Undisturbed unconfined compression by disturbed remolded soil compressive strength. Thixotropy. Now thixotropy. If a remolded clay sample with sensitivity greater than 1 is allowed to stand without further disturbance and change in water content, it may regain at least part of its original strength and stiffness. This increase in strength due to gradual reorientation of the absorbed molecules of the water is known as thixotropy. Regain of increase of strength due to reorientation gradual reorientation increase in strength due to gradual reorientation of absorbed molecules of water is known as thixotropy. That is thixotropy. Dots to changing increase of the strength due to regular gradual reorientation is thixotropy. Plasticity chart. This is plasticity index versus liquid limit chart shown here. Higher plasticity U line, A line. Plasticity index. This the chart is into 6 region, 3 above and 3 below the line A. Line A. This is line A. Classification of soil by this line. The chart is given to 6 region, 3 above and 3 below the line A. The equation to line A is IV plasticity index equals 0.73 liquid limit WR minus 20, and equation for this line U equals to 0.9 WR minus 8. This is plasticity index chart use. This limit is used for the classification of soil. 0.7 WR minus 20 IP. Now numerical examples. Determine the times required for particles of diameter 0.2, 0.02 to fall a depth of 10 cm from the surface in water. That is, this is from Stokes law. Stokes law given coefficient of viscosity equals to 8.15 10 to the power minus 3 poise. Specific gravity equals to 2.65. Note that 1 poise equals to 10 to the power minus 3 gram second per cm square. This is viscosity in terms of gram second cm 10 to the power minus 3 1 poise. So 1 poise 10 to the minus 8.15 into 10 to the minus 3 into 10 to the minus 3 gram second per cm square is, we have to determine time equals to 30, time t equals to velocity equals to L by T, and diameter we have already know the formula. Diameter equals to K times C here. Stark's law. Velocity equals to L by T. Diameter equals to this. D equals to K under root L by T. Okay. From the equation we get T equals to 30 mu by Gs minus 1 into L by D square, where D equals to K into root over L by T. L by T. T equals to K into L by D square. K equals to K square. K square. K equals to root over 30 mu by Gs minus 1. K square y equals to 30 mu by Gs minus 1 into L root by D square. We have already seen this time T. We have to find the time required for the particle's diameter. These two fall for depth of 10 cm. There is a diameter given, length is given. We directly from this equation determine this. Now 3.10 sedimentation analysis by hydrometer method. On pipe to H was conducted 50 gram mass of ash swale is over dried and volume of swale suspension given. Hydrometer reading RA after a lapse of 60 minutes after the commencement of the test. After 60 minutes, RA hydrometer reading RA given Cm equals 0.52, L effective equals to 14 cm, 0 correction plus 2.50, SGS specific gravity 2.70, poise. Okay, now solution. We know D equals root over 30 GS and L by T always. Mu equals to into 10 minus 3 grams second per cm square. All are converted in grams second cm unit is used. So diameter first we have determined. We have to calculate smallest particle size which would have settled depth for 10 cm. Percent is final, then this side temperature is 25 degrees Celsius. Diameter equals to 0.064 mm. From equation RC equals to RA minus C naught plus CT. RC equals to RA 19.5 minus C naught 2.5 plus CT 1.3 18.3. We know P percentage, this formula CSG by RC into 100%. CSG equals to 1.65 GS by GS equals to 2.5 by 2.65 GS minus 1. This CSG is calculated, GS is 2.7 and CSG RC equals to after temperature and 0 correction applied RA minus C naught plus CT, this formula. Then CSG equals to this 1.65 in CSG, then percentage speed S equals to CSG RC by RC equals to RA minus C naught plus CT. RA given, C naught CT given, RA minus C naught plus CT, CSG equals to 1.65 GS by 2.65 GS minus 1, MS equals to given, then CSG equals to calculated, then P percentage PDS equals to 36.23 percentage. Calculate the special particle size percentage final, then this size percentage final, then this size. Next is 3.11 or 500 grams